is 3, which means x equals 3 and y equals 3, and we can check that. Now, perhaps some of you are lazy like me, and sometimes being lazy is good, because if you're lazy and it helps you develop quicker ways, easier ways to do things, there's nothing wrong with that. You might be saying, wait a second. When we solved those systems of equations for x and y earlier, once we solved for x, we replaced x in the equation with that number and solved for y. Why can't we do that here? And you're absolutely right. In fact, you should do that. I am just doing these determinants just to give us extra practice where you'll have the answers so you ensure that you have the right determinant. As soon as I solved for x using Kramer's rule and got x equals 3, I would have gone back to one of those equations, plugged in 3 for x and solved for y, and checked in the other equation. Now, let's go ahead and look at a 3-equation, 3-variable system of equations, which we'll find on the next visual. These 3 equations should look familiar to you. These were the equations we did in the very first problem of this type in Lesson 12. In fact, you might even remember the answers, because remember I said this problem demonstrated that solving 3 equations was as easy as 1, 2, 3. That's a hint. If you don't remember, maybe now you do what the answers for x, y, and z are. And hopefully, by using Kramer's rule, we'll get the same answers. If we don't, then something's wrong. Okay, what's the first thing we're going to do? The very first thing we're going to do is we're going to get big D. So, before we look at what that might be, what you need to do is write down the matrix of the coefficients right now, and then you need to find the determinant of that 3 by 3 matrix. You may have forgotten how to get the 3 by 3 matrix determinant. You need to go back, rewind the tape, back to the previous lesson, lesson 26, and find out how to do it. So right now, turn off the tape, find big D for this problem, and when you come back, we'll have the answer for you. All right. Hopefully you're back. And let's look at the visual. The next visual shows us that big D for this problem is 26. If you didn't get 26, I would suggest you stop right now, go back to lesson 26, and see how we get the determinant for a 3 by 3 matrix. It's just a bunch of multiplication, some addition, and 1 subtraction, and you should be able to get 26, because that is the correct answer. All right. Now that we have big D, we're going to solve for x, we're going to solve for y, we're going to solve for z using Kramer's rule. And then we're going to do one final problem that will help us demonstrate once and for all that we can use Kramer's rule to solve a 3 by 3, should say a 3-equation, 3-variable system of equations. So the next visual shows us the solution for x. Okay? In the numerator, we have the determinant, a 3 by 3 determinant, where we've replaced the first column, the coefficients of x in the 3 equations, with the 3 numbers that were over there in the on the other side of equals. 2, 3, and 1. I'm sorry, we replaced the 2, 3, and 1 with 5, 5, and -6. And when you start working with 3 by 3s or 4 by 4 determinants, it's very important to double check, because it's easy to make a mistake, as I just did, and put the wrong numbers in someplace. We want to replace the first column with the 5, 5, and -6. The answers on the right side of equals, and every other number stays the same as it was in big D. When we work this out, and again, you might want to stop the tape and work it out by hand to ensure that you get the right determinant. We get 26, as you'll see on the visual. And of course, now we have 26 divided by 26, and this equals 1. So x is 1. Now we need to get y. To get y, we are going to take the determinant of a 3 by 3 matrix that is the same as big D, except we're going to replace the coefficients of y, that is the second column, with those 3 numbers. That was 5, 5, and -6. That can be seen in the next visual. Again, we see the determinant we just described in the numerator, 26, which is big D, in the denominator, and we get 52 over 26, which is 2. So y must equal 2. Now all that's left to do is find z. Again, since we have x and y, we can go back to one of the original equations, plug in 1 for x, 2 for y, and solve for z. But just to give you the extra practice, we're going to use Kramer's rule to find z. We're going to take the original coefficient matrix, that is big D, and replace the third column, the z coefficients, with 5, 5, and negative 6, and solve. And the next and last visual shows us that. We've replaced the third column with 5, 5, negative 6. All the other numbers are as they should be. We divide that the determinant by 26. 78 divided by 26 is 3. And once again, we get x equals 1, y equals 2, z equals 3, as easy as 1, 2, 3. Again, as I said before, earlier in this lesson, this may not seem as easy as I think I'm saying it's easy, because you haven't done enough of these. You do a few of these, and I think you'll see, just like that class back a few years ago said, this is great, we can do this, there's no problem, and in fact, they got a 100. Now, what I like to do is go to the board and work a problem, or have you work a problem. We stop the tape. Let's see. This is another problem. This was the second problem in lesson 12 of this type. 2x minus 2y plus 3z equals 10. And 3x plus y plus 5z equals 3. And 5x plus 3y minus 2z equals 1. Step back a moment, double check it, make sure I've copied everything correctly, because it's one thing with a simple equation, if you make a mistake, you go back and it's easy to correct. Here, with these three equations, if you start doing all the work and spend a few minutes doing it, and then you find out this should have been a 4 or this should have been a positive 2, you really feel bad about it, you want to cry. And it's terrible crying, because then you get tears on the paper and everything's a mess, and you know. Anyway, what are we going to do first to solve this? We want to get big D. I'm going to leave this up here, and let's get big D over at our friendly easel. Okay? What's big D going to be? It's going to be the determinant for, let's see, 2 and 3 and 5, negative 2 and 1 and 3, 3 and 5 and negative 2. Once you look at that, well, I step back over here and make sure that my equations and my big D determinant are the same. 3 and negative. Looks good to me. Well, now what I would have you do is stop the tape and get this determinant. Why don't you do that right now? All right. Hopefully you did it, or else you cheated, but that's okay. It's up to you. I get a big D of negative 84. Hopefully you got the same, because I'm right. I double-checked it myself. And, of course, it also gets the right answers. So there's our big D. What do we want to do? We want to solve for x. In solving for x, we are going to take the determinant, what we have here, and take out the first row. Oh, sorry, I should say the first column. Leave the other columns the same. And replace this first column, the x coefficients, with the numbers right here, 10, 3, and 1. That is the numbers on the other side of equals. Find that determinant and divide it by negative 84. In fact, why don't you do that? Why don't you find that determinant, divide it by negative 84, and see what you get for x. Stop the tape. Start the tape. Very good. Okay, what did I get? Well, I got negative 168. Hopefully you did too. Because when we divide that by negative 84, even though the numbers are fairly large, we get x equal to 2. And you know what? That's the correct answer. How did I know? I went back to lesson 12 and saw how I did it there, and I got x equals 2. How about y? In y, we're going to do the same thing. We're going to take this, and now we're going to put our x coefficients back, replace our y coefficients with 10, 3, 1, leave our z coefficients alone, that's a negative 2, and divide by big D, which is negative 84. Okay? Again, I think a good idea, go ahead and turn off the machine, figure it out, and come on back when you got it. You got it? Good. I got it too. I did this and I got, what did I get? I got 252 for my determinant for that matrix, and we got to divide that by negative 84, and nicely enough, 84 goes into that 3 times, so y equals negative 3. And the really nice thing about z, we'll do that fairly quickly, is when you take the determinant of z, which you'll get, go back up here and replace the z coefficients with 10, 3, and 1, you get 0. And what's really nice about that is 0 divided by anything, including negative 84, is 0, and that's it. X is 2, y is negative 3, z is 0. It will check, and we're done. Except I have one question for you. I'm surprised, maybe you did think about it. Obviously, if you thought about it, you couldn't raise your hand because we don't have interactive TV yet. But what would happen if instead of getting this determinant to be 0, if our big D was 0? What would that mean? If when we solved for the coefficient determinant, we got 0, it would mean that there wasn't a solution. There was some problem there because you couldn't solve x equals something over 0. Okay? And that's called an indeterminate situation. There's no determinant. There's no big D. So we've seen in this lesson how to use matrices and determinants to solve systems of 2 and 3 equations. In our next lesson, we will look at recursive equations, which has nothing to do with cursing. If you want to know what they are, stay tuned.